Hello, let's do the New York Times Hard Sudoku for March 6, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. We don't have any repeat digits in this top band. Let me see if there's anything else we might be able to do, though. I'm thinking about crossings, like this 6-1 come in like this against this 9-8. So we're looking for 6s and 1s down here. You probably see it. There's a 1. So this one looks in, this one looks in, and that's always going to do something interesting. So there's a 1 in one of these two, which we can mark with corner marks. And what that means is in this column, we can't have more 1s, right? There's a single 1 in every column, just like there's a single of every number. Well, the 1 is up here, right? This box needs a 1, and it's going to be in one of these two cells. Both of those are in column 9. So if the 1 is up here, it's not down here. So none of these are 1. Importantly in this, it already wasn't 1 in this box because of this one, but importantly in this box, that's interesting. So this one looks into this box, this one looks into this box, and it means 1 is only in one of these two. The important thing for us to remember, which this corner mark and this corner mark are attempting to help us remember, is that these can't be 1 anymore. In fact, these two are the ones to remember because this already couldn't be, right? So that's one thing that corner mark is doing for us. While I'm looking at this, I did see we have two 8s looking in here, and then this 8 looks up, right? So there is an 8 placed in this box. And then now those two 8s look up, this 8 looks in, placing that 8. Now these two 8s look over, putting an 8 in one of these two. Let's have another look at 8s. Okay, 8 ends up in one of these two, and it ends up in one of these 3. Okay, I don't mark 3 unless they're all in a line. And sometimes I mark too many of those when I don't need to, but I tend to, in these puzzles, I tend to just mark it whenever I see it. This 3 is looking into this box, placing the 3 in the box, and we're left with a triple, which should be helpful. 4, 5, 6. This 5, 6 looks in, so this cell can only be 4. The options are 4, 5, and 6. Can't be 5 or 6. Must be a 4. That's a naked single. And then we have a 5, 6 pair here. I'm noticing we have a 6 here already, and this 5, 6 pair, the way a naked pair works, let's go over that, because I kind of have, in a lot of videos, assume you know how a naked pair works, and I get comments saying, hey, how did that work? So let's go over it. There's no reason that you naturally have to understand it, but if you put some thought into it, it becomes pretty natural. So if you put in some thought into it the right way, and this is a nice primer on how to think about logic in Sudoku in general. So this is called a naked technique. It's called a naked technique because if you were to go through, if you go into these cells and you just see what digits are remaining for those cells, then the technique becomes nakedly visible. So that's where the naked comes from. Unfortunately, nothing a little bit more central than that. So in this case, these two cells see the 1, 2, 3, 4, 7, 8, 9 in the box, right? So they only have 2 options each. They can be 5 or they can be 6 each. Now, the other thing to notice is that they are in the same column as each other. And they're also in the same box, which also works. In this case, I'm going to pick the column because it directly affects the column here. So where are the 5, 6 going to end up in this column? And you could say, well, this could be 5 or 6. This could be 5 or 6. This could be this actually can't be 5 or 6. But these two could be 5. Like, why would it have to end up here? But I'm going to say they will end up here because there are only 2 ways that these two can resolve. They're either going to resolve like this, 5, 6, or they're going to resolve like this, 6, 5. Those are our 2 options, right? They can't both be 5. They can't both be 6, right? Can't repeat that in the column. And so also can't repeat in the box, but we're dealing with the column right now. So if it's like this, 5, 6, well, we're certainly not putting another 5, 6 here. If it's like this, 6, 5, we're still not putting another 5, 6 here, right? We can't repeat in the column. So ultimately what happens is the 5, 6 are here, right? Because those are the only values these can be. If the 5, 6 ends up elsewhere, like if I put a 5 here, these both have to be 6 or one of them ends up empty, and that's very broken. So that is how a naked pair works. I hope that's understandable for those who didn't understand that before. And so that means these can't be 6, importantly, and this 6 looks down, so these can't be 6, and that puts a 6 in one of these two cells. Let's look at this row, because this row has only 3 open spots. That means there's only 3 digits left that need to be placed in the row. They are 2, 3, and 9. All right, I'm saying this sees a 9, but I'm not seeing, and this sees a 2. Yeah, I'm not seeing anything else. So I'm just going to fill 2, 3, 9 and clean that up. 2, 3, 9, that's not a 2, that's not a 9. What else can I do here? 8s, 3s. I am noticing we have 2 5s here looking up, and then this 5 looks in. So 5 is in one of these two. Now there's 2 in a box. It's always good to just mark that so you can remember for later. It's often useful later. I got the 8s. Let's see. I'm trying to see if there's anything else to do here because I feel like there ought to be. But also I'm not... okay. So I found another crossing. So this 9 looks into this box and it crosses past this 5 8, and this 9 looks down. So there's a 9 in one of these two cells as a result. And so now those, if the 9 is here, then it's not here, right? Excuse me. Oh. So to go over that again, the 9s are here for this box. The box has told us the 9s have to be in one of these two, because this 9 looks in here, this 9 looks in here, 5 8 aren't 9. And so if the 9 ends up in one of these two, it's not going to end up down here. That's pointing, right? We did that earlier with the 1s, I believe. So if the 9's not here, and then this 9 looks down and it's not here, then that places the 9 in this box. This is actually the only place we can put 9 in the box because of this pointing logic. So we can place it. Now I'm scanning to see what the consequences of placing that 9 are, right? And there's a lot of consequences that can happen. First of all, it can affect the row, and in this row of boxes in general. So you kind of want to look for other 9s around that area. It can affect the columns, although we got it from the columns, so it doesn't really give us any more information than we already had. It can affect the column in general in that now there's a spot used up, right? There's one fewer slot. So I'm just going to think about what digits can be placed still in this column or need to be. We need a 2, 3, 4, and 6. 2, 3, 4, and 6. So this is 3, 4, 6. This sees a 3 and a 6. I'm not really too interested in marking these up, though. The thing I was mostly looking for is whether occupying this caused us to just have a nice pattern or single happening up here, but it did not. I'm also going to look at the box. It used up a cell in the box. So what are the remaining digits? 2, 3, 6, 8. 2, 3, 6, 8. So this can't be 3 or 8. So this is 2, 6 only. This can't be 8. So this is 2, 3, 6. And I am going to mark that because I've noticed it kind of matches this 2, 3. If I find one more like that, then I can get a triple, a naked triple out of that. I think these are from 2, 3, 6, 8. Just generally, I don't think we want to mark 4. So we'll skip that. We do have these two 1s looking in here, though, and this one looks down. So there's a 1 in one of these two cells. By the way, do we have any other crossings on this? The 8, 9, 2. No, none of those really are helpful. Okay. Anything else to do down here? We do have two 7s looking in here. Oh, this is helpful. This 7 looks down. So that places this 7. Now these two 7s look up, and there's a 7 in one of these three. Just meant it was helpful because it placed the 7. So this 4 looks in, this 4 looks down. That's not quite good enough for us to do anything with. Let's look at this column, because we just placed this 7 here. It doesn't really help the rows and columns directly, but it does limit 7 out of these cells. So let's think about what's needed. We need a 2, 4, 5, and 9. I mean, I see this 5, I see this 9, I see this 4, and 9. Okay, this sees 4 and 9. So this is down to 2, 5. 2, 4, 5, 9 are our digits remaining. So this is 2, 4, 5, and this is 2, 4, 9. I'm not super interested in that at the moment. How about these 4? We need 4, 5, 6, and 8. So this is not 5 or 8. Or, yeah, so this is 4, 6. 4, 5, 6, 8 is what I said. This is not 5, 8 either. So this is 4, 6. Oh, it's not 6 either. Okay. So this column, if you see, you need 4, 5, 6, and 8. 4, 5, 6, 8. This sees 5, 6, 8, the cell here. And so it has to be a 4, because it's got to be one of those numbers, and it's not 5, 6, or 8. So it's going to be 4. That's a naked single. And that looks down. That makes this a naked single now, because now we have 5, 6, 8 left, and this cell sees the 5 and 8. So that's a 6. And then we're left with 5, 8. This 6 looks right. This could have been 2, 6. Can't be 6 anymore. So now it's only 2. That's a naked single. That removes 2 as an option from those cells. These are from 3, 6, 8. And at this point, I am going to mark it. It really just comes down to how limited I think other things are around it and whether it's going to resolve quickly. Is kind of when you really want to mark it, just to save yourself time later, because you're going to have to look at it again soon anyway. So you might as well mark it while it's fresh. This is a 4-9 pair for the row. That's just what's left for the row, and that does affect the rest of the box, removing 4 and 9. So if we think about, yeah, okay, we do have, I was thinking about 4 in this box. 4 in this box is placed. I was thinking about how it had to end up down here, but then I saw that there were these 2 4s looking down. Let's just think about what this box needs. Whenever a row column box is down to 4, and I notice that, I just want to look at what's left, because often you can find something nice. We are down to 2, 5, 8, 9. So yeah, what I noticed is that 9 looks in here, 9 looks down, so 9 is placed here. The only place that can be 9, so it is 9, and then 2, 5, 8 go here. But the 5, 6 pair or the 2, 5 pair. So the 2, 5 pair, importantly, yeah, I guess the question asked is where does 8 go in the box, and it goes here. But also the 2, 5 pair, remove 2, 5 as an option from here. Just like this 5, 6 removed 5, 6 from the rest of the column. So that's an 8. Oh, wait, no, it's not the only place for 8, because that's not a 2, 5 pair. What am I talking about? I imagined a 2, 5 pair there. I apologize. Ignore what I just said. However, this 5, 6 pair does remove 5 from here, so we can at least do that. But this is not resolved. I was literally seeing things. I was imagining a 2, 5 pair there. This would have had to been 2, 5 if that were the case, right? But it's definitely not. Sorry, let me undo that. Okay. All right, well, let's see what else is going on in this column, because we are down to 4 digits, because I'm counting this 5, 6 pair as quasi-resolved, right? We basically know where the 5, 6 are, and they aren't here. So this is down to 4 digits. We need a 1, 2, 7, 8. I mean, these are both 1, 2, 7. I'm not sure if this area is gonna, well, I am gonna fill in 2, 7, because I think these 3 left might be helpful. So we need 2, 5, 9 here. Yeah, so if I fill out 2, 5, 9, you see we have this 5 and this 9 here. So those are down to, yeah, so 9 in this column is what I was supposed to be seeing. These 9s see here. So 9 in this column goes here, or you can use this 2, 5 pair to eliminate 2 from here, and now it's a naked single 9. Either way, you get that 9. Let's follow up on the 9. The 9s look into here, so 9's in one of these 2. This can't be a 5 because of the 5, 6 pair. So 5 ends up in one of these 2 cells. We're down to 1, 2. No, we're down to 2, 7, 8 here because it can't be a 1. All right. All right, let's find somewhere else to look. Let's see. I did get this 9 recently. There's still 5 open cells in this row, so I'm not sure if I want to do anything with that. I might. Might as well think about it. We need a 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. I mean, this can't be 1, 2, so this is 3, 6, 7, but yeah, I'm not seeing anything super special going on here. This can't be 1, 7. All right, I want to look at this column then. Did I already look at it? Not sure, but it needs 2, 3, 4, 6. So the 2 ends up here. And we know the 2 in this box is one of, oh, the 2 in this box is placed. Got it. There's 2 2s looking in here, and this 2 looks up. So we get this 2. That's nice. I should have seen that from this 3. I don't know when that happened. I've been missing that for a while though. All right, the rest of this column is 1, 3, 6, 7. This can't be 1 or 6, so it's from 3, 7. I mean, this can't be 3, so it's 1, 6, 7, but what else can we look at here? I feel like the cross of these digits with these digits might be interesting, along with this 8. The 8's repeated, the 1's repeated. No, but we still have quite a few digits looking at this. So what can this actually be? It can't be 1, 2. It could be a 3. It can't be 4. It could be 5. It can't be 6, 7, 8, or 9. So it's down to 3, 5 only. This one's not as nice. It sees the 5. Okay. I think I need to look elsewhere. this cell sees the 4 and the 9 and the 5. So this isn't 1, 2. It could be 3. It can't be 4, 5, 6. Could be 7. Can't be 8, 9. Huh. Now these are not a pair because they don't affect each other. They could both be 3 or both be 7 just fine. So we can't prove that they're a pair, and therefore we can't do any logic off that yet. If they ever become a pair, that will become apparent, and then we can use that. But they aren't naturally a pair because they don't. You can't cover them both, right? With a row, I need 2 rows. With columns, I'd need 2 columns. With boxes, I'd need 2 boxes. There isn't a singular row, column, or box that I can use to cover both of them, that they both reside in. So they aren't naturally a pair. Sometimes you can make what's called a remote pair out of them, but that's a bit more advanced and never really needed in these New York Times puzzles. But if you do spot it, no reason not to use it. Let's see. I've kind of lost momentum on this puzzle, so I'm trying to gain it back. So let's do that. Where am I looking next? Are 2s interesting? Not really. Okay. Let me start a scan over here, and let's see what I've missed along the way here. It might be a vertical scan that I didn't quite complete. Though it seems like I got it all. Okay, it seems like maybe the key is finding restricted cell, continuing to find restricted cells. Remember that these can't be 1. Maybe that's still important here. So let's go over what these can be, I suppose, because they can't be 1 or 2, because there's a 2 in the box. 3 can go here, but not at the bottom. We do need a 4 that can go in either. We can't be 5. We do need a 6 and a 7. This can't be 8, 9, or neither can be 8. This one can be 9. Darn. So even though they can't be 1, they still are very open in what they can be. Yeah, the 2, 8, 9 in this row is already in this column, so that doesn't actually restrict this cell at all. The only thing restricting it, even the 5 doesn't restrict it. So just looking at the column, that's what it can be, unfortunately. 1, 3, 6, 7. This one can't be 3. I'm going to fill the 1, 6, 7 at this point. I am on the prowl for something a bit more. So we're going to have to pencil a bit more. This is a bit of a sticking point. So let's find it. What else? Okay, so techniques for looking for restricted cells. First is something I've been doing all along, which is rows, columns, boxes with 4 or fewer digits that need to be placed. Right, 4 or more or fewer open cells. I think I've covered them all. Sometimes 5 can be useful if you run out of the 4s. It's always worth at least just giving them a glance, like this one here, right? We know that this sees 4, 7, and 9 in addition to what it sees in its column. If we just count, that's already 7 digits. So it's down to, there's only 9 digits total, so it's down to 2 digits at max. And if I missed anything, it's a single. But it sees 1, 2. It can be 3 or 5. Can't be 4. Sorry, 3. Starting at 3. Can't be 4. Could be 5. Can't be 6, 7, 8, or 9. And now we get this 3, 5 pair. There we go. That's what I was missing. So this is a 3, 5 pair, meaning this can't be a 3 anymore for the reasons we discussed earlier, right? Another way to look at this, if this was a 3, what am I filling in these two, right? They're down to only 3 and 5. So, and I didn't say, hey, 3, 5 in this column or 3, 5 in this box can only go here. I just looked at what these cells could be, and they both matched as 3, 5. That's a naked pair. That removes 3, 5 from the rest of the column and the rest of the box. So this can't be 3. This is a 7. This is down to 4 or 9 for the column. I just noticed that from that. 3, 5, 6, 8. Okay, so this is a quad. You might want to look at this as the other side of the coin, but let's look at it both ways. If I say the numbers 3, 5, 6, 8, that is 4 numbers. That is 4 unique numbers, 3, 5, 6, 8. These 4 cells can only be from 3, 5, 6, or 8. Now, some of them can't be 3, some of them can't be 5, some of them can't be 6, some of them can't be 8. Doesn't matter. What matters is I am trying to spread 4 digits, 3, 5, 6, 8 is 4 digits, across 4 cells. I need to use all of my digits to do that. or I ran out of butter, right? If I want to butter my whole bread, I need enough butter for the bread. I need to fill these 4 cells, and the only digits I have to fill them, if we look at any digit the cells mention as being possible in them, is 3, 5, 6, 8. So that is a naked quad. And that eliminates 3, 5, 6, 8 from these 2 cells, leaving 1 and 2 left. They would see everything else. They'd see 3 in the 3, 5, 6, 8. They'd see 4. They'd see 5 in the 3, 5, 6, 8. They'd see 6 in the 3, 5, 6, 8. They'd see 7, and they're going to see an 8 in the 3, 5, 6, 8, because all 4 of those digits will appear in these 4 cells. So this ends up 1, 2. There's always another side of the coin, though. And this might be a little bit easier to see in this case, which is the other side of the coin is there's always a hidden version of the same technique. And so we can do counting here. There are 6 open cells in this row. If we found a naked quad, that means 6 minus 4, the remaining cells, 6 minus 4, 2. That means there is a hidden pair. So if there are 6 cells left and we have a naked quad, we will always be able to find an equivalent hidden pair. If it was a naked triple, it would be a hidden triple. If it was a naked pair, we'd have a hidden quad, right? They always add to the number of cells remaining. Because we're taking out these from the row entirely, right? And so what we want to ask is, where do 1 and 2 go in this row? Where do 1 and 2 go in this row, right? Well, these can't be 1 or 2 because they're already filled with different digits. This can't be 1 or 2 because of this 1, 2 here. This can't be 1 or 2 because of this 1, 2 here. And then this 1, 2 in the box, take it out of these 2. So there are only 2 cells left in the row that can be 1 or 2. So they must be 1 and 2, right? Because we need 1 and 2 in the row. We need 2 cells for them from the row to do that. And these are the only 2 cells that can. So this ends up 1, 2. The result is exactly the same. The result of the naked quad and the result of the hidden pair is that these 2 cells are down to only 1, 2. Whatever else we thought they could be, they cannot be. In this case, the 3, 5, 6, or 8. So that is how you view those. And now we have a 1, 2 pair, a 3, 5 pair, and a 4, 9 pair accounted for in this box, and the 7, 8. So the only digit I didn't mention is 6, and that goes in this open spot right there. That's a 6. That removes 6 as an option here. Means 6 is in one of these 2. All right. That was hopefully that was a nice explanation for y'all. This puzzle's already long, so I might as well make it longer by teaching a bit more. Do let me know if you have questions. I can always do follow-ups. Let's see. We need 1, 2, 3, and 6 here. Has that improved at all? This is all of them. This can't be 1, so this is 2, 3, 6, and this can't be 2, so this is 1, 3, 6. Not super amazing. I'm trying to see what this 1, 2 pair got us, basically. I'm not seeing it. Okay. So we got to spot more. 3, 6, 7. Trying to find, okay, so we were looking for restricted cells. Let's continue to do that. So I was saying that we can look at rows, columns, boxes with 4 remaining first, like this one here, but this was down to 1, 2, 3, 6 though, so I didn't mark it because it was 4. I know I marked these, but that was a special case because I wanted to remember that they couldn't be 1, and at this point I want to bake that into their center markings. But normally I only mark 3 or fewer, and I'm a little bit hesitant to do 3 early on. But now I will do all that are 3 or fewer. And so you want to find the cells that are 3 or fewer. How do you find them? Rows, columns, boxes with 4 or fewer remaining. Sometimes 5 or fewer remaining if you get desperate. You can't find other ways to find them. Another thing you can do is you can look at your corner marks in your boxes. Like this was an example where it's avoiding the 1, the 2, and the 5 corner marks, which means we already know it can't be 1, 2, or 5, in addition to anything else it can't be. And so it might be more limited than you'd expect. That's a good way to find limited cells. You can also look for cells where, like I did here, I think it was here. Maybe not this one. I forget which cell I used, but a cell that just sees a bunch of unique digits in its row column box. Can can often be helpful. This 2, 3, 5, 8 is bothering me. It doesn't resolve as far as I can tell, though. We know the 1 is in one of these two. Okay, the other thing you can always scan for is, with corner marks, is have I respected my corner marks? Like my 1 corner marks here. Like, did I remove 1 from all of these? I did, right? Like the 7s, the 1s. Often it's the non-trivial ones, like the interesting corner marks, that are the ones that are going to remove from the rest of the box that you want to try to pay attention to. You want to try to pay attention to pointing to make sure you've respected that, things like that. I'm trying to recall, and I think these 1s were one of the few that actually did something interesting, that we haven't like just ended up placing digits as a result. So, excuse me, my throat's having issues today. Let's see. So as a last result, we can we can just start looking at cells. But yeah, I'm not seeing like some really obvious. Ooh, okay, so something I am seeing is these 7s. I missed this for a while. That does put 7 in one of these two. These might be interesting because they aren't the 7, 8. They aren't 2, 6, 7, 8 already. 2, 6, 7, 8. That's 4 digits. We only need 2 more digits seen to be down to 3 or fewer, right? Because we need to see 6 digits to be down to 3 or fewer. So we're not the 2, 6, 7, 8. This one's also not the 3. That's still not good enough. Yeah, these can't be 5, but they can be 7, so it doesn't really help. Unfortunately, this 8 here is already in the box, right? The 3's in one of these 3. Right, I'm not seeing what I'm supposed to see here. Sometimes just thinking about what a row or column needs and then scanning down to see if it just sees a bunch of those is helpful. Maybe this cell, right? Because we got a bunch of digits here and some over here. So this is already 1, 2, 3, 4, 5. We just need one more unique one to make it down to 3. And here's our 3, right? 3 isn't in the column yet. So let's mark this one up. It can't be 1. It could be 2. Can't be 3. Could be 4. Can't be 5. Could be 6. Can't be 7, 8, 9. So down to 2, 4, 6. This is 2, 3, 4, 6 for the column. I think at the time I just decided not to pencil it, but now I'm penciling all the 3s. So, this isn't 1 or 2 or 6. That's it. Wow. Okay, let's take a step back. What am I not seeing about all this? I was looking at these 4 9s to see if I could do anything with that, but I didn't see anything super useful. We got this 2, 5, 8. We got this 5, 6. We got this 3, 9. I do have 2 6s looking up here, and this 6 looks in. So 6 is one of these two. Not entirely sure that's helpful. This cell's avoiding the 6 and the 9. Let's think about this cell. It could be 2, can't be 3, could be 4, can't be 5, 6, 7, 8, 9. Okay, so it's down to 2, 4. We have a 2, 4, 6 here. We also have a 2, 5 here. So both of those are candidates for a triple of some kind. This can't be 1. So 1's down to these 2 cells. Can't be 1 or 5. So what can it be? It can be 2, 4, 6, and that's it. Okay, so this, wait, what about? Oh, I also need a 7 in the row. Yeah, that's what I was missing. Okay, so we've got this 1, 5, and 7 here. I missed this New York Times trick after I placed that 7. It's called a New York Times trick because it appears in the New York Times a lot early on. But really what we're finding here is, I found this naked triple. What's the other side of the coin if there's 6 cells remaining? It's a hidden triple. And so one way we could have found that hidden triple is noticing that this box has 1, 5, and 7 in it. And they are avoiding these cells here. Right. Well, they're avoiding row 2, right? They're in 2 rows, not 3, right? So they're avoiding row 2. And so we know that row can't be 1, 5, or 7 because the box already has it, right? But the row's going to need a 1, 5, and a 7. We also know that these given digits are not 1, 5, and 7. And then we also know that this digit here is not 1, 5, or 7 because of those givens there. So that leaves only 3 cells left in that row that can be 1, 5, 7. We need 3 cells for 1, 5, 7. And these are the only 3 that it can be. So we can't put anything else in here. We can only put 1s, 5s, and 7s in there. So this can't be 2. This can't be 2. And this is from 1, 5, 7 only. Now notice now, since this can't be 2, it is only a 5. That removes 5 from here. That makes this cell an 8. We look down here, we get 5, 2, and 8. This can't be an 8. Down here, we've got the 3, the 6, and the 8, 3 and 5. It looks like we might be collapsing at this point. I am going to get rid of these colors. All right, we need this. This is a 9 now. This is a 3 now. This can't be 6. This can't be 9. This can't be 3. That can't be 3. Okay. So we just got a flurry of digits. We want to try to follow up on that if we can. Continue with what we've learned. I do have this 1, 2, 7 triple here that I found. We've got this 2, 4, 6 triple that I found. We got this 1, 7 pair. This column is down to 3 digits, 1, 3, and 7. This can be any of them. So it's not immediately helpful. Do I have to find more? That would be crazy. It felt like we were done. But at the same time, we don't seem to be. Let's see. Is this at all reduced? 1, 2, 3, 6? Can't be 3. So this is from 1, 2, 6. Oh, it can't be 1 or 3, right? So this is down to 2, 6. I probably should have marked this earlier. That's a 2, 4, 6 triple in this box. So the remaining digits are 3 and 9. Basically, where do 3 and 9 go? Well, 3 and 9 do not go. Interestingly, this 3 looks up, this 3 looks in. So 3 can only go here, and that place is 9. All right, that's 7 and 2 and 1 and 7. Now we have progress again. This is the 1 and the 6. This is the 2, 4, and 6. We get the 1 and the 2 and the 9 and the 4. We get our 1, 3 here. This is a 4, 7 pair. Basically, where is 6? It goes here. That's 3 and 2. That's a 9. We got the 5 and the 6. This corner mark 5 is alone. That means that's a 5. We have the 4 here. What's left? 1, 4, 5, 7. So this is the 1 and the 7. This is 4 and 7. And we need 4 and 5, which go 5 and 4 go like that. And we're done. All right. So what I missed for a while was this hidden 1, 2 pair. And then this hidden 1, 5, 7 triple. Or alternatively, this 2, 4, 6 naked triple. And this 4, 5, 6, 8 naked quad. Both are the exact same logic, right? They're just reverse sides of the coin. So whichever you find first, great. Often if you aren't fully notated, the hiddens are easier to find. If you are fully notated, the nakeds are easier to find. That's why they're named that way. Well, really, they're named that way because people used to just always go full candidate. And when you're full candidate, it can be hard to spot the hiddens because you can't see the forest for the trees, or you can't see the trees for the forest. I don't know what the better analogy there is, but when you can't find the needle in the haystack. Might be a better analogy there. So you're just overwhelmed with information. You're not going to notice that, oh, hey, in this row, only one of them can be a 1. Like, you have to explicitly look for that. And it can be hard to spot hiddens if you're fully notated. Whereas if you're not fully notated, you might just notice it from the givens, right? That, oh, the 1 can only go there because of various places I've given 1s prevent me from putting 1 anywhere else, right? Somehow these weren't 1, right? So anyway, hope you enjoyed this little more in-depth analysis. I'm sorry I got stuck a little bit in the middle there. I think those weren't necessarily easy spots. This triple that I found, this hidden triple that I found, was only unlocked when we the 1, 5, 7, only unlocked when I placed this 7. So it wasn't there from the start. I'm looking and I don't think the 1, 5 was helpful from the start because it could have been in 3 places. So we needed that 7 to solidify it. All right, and yeah, so I hope you enjoyed this. And if you did, then why don't leave a like, subscribe, and a kind comment below.